Positively Perfect Problem Solving presents Solving Basic Equations. Today's learning target is one of the most important learning targets in algebra. It's solving equations. We're going to start off with basic equations today. I don't want to overwhelm you. I know you've been doing this since middle school, so we're going to talk about the most basic types of equations that we need to know how to solve. This video might take a little time, so if you need to take a break in the middle, please do, but keep in mind that this is a skill that you need to master. It's not a skill that is okay to make mistakes on, and if that means this takes you a couple days to do it, I am totally fine with that, okay? So let's start off by talking about what a solution to an equation is. A lot of you guys say things like, I'm solving this, I'm solving that, when really you're simplifying or you're rounding or you're doing something else. Solving means something very particular. Solving and a solution means that you're finding a value of x or any variable. I'm going to use x because it's the most common. But we can also say or any variable, not just x. And this value of x for a solution is the value that makes an equation true. So when I get a simple equation, I can usually solve things logically. Like I can look at an equation and just kind of see what makes sense. So when I look at x plus 5 equals 7, this is saying what added to 5 gives you 7. Hopefully my pen cooperates here. So what plus 5 equals, and I'll write the word equals 7. Now without doing any like cool solving qualities, I can be like, oh duh, it's 2 plus 5 equals 7, so that means that x equals 2. I didn't do any of the move things to other sides. I just logically know that, well, x has to be 2 for 7 to equal 7. Okay, so when I plug in the 2, I get 7 plus 2. 2 plus 5 is 7. This is similar over here. I'm asking the same question, like what minus 10 equals 1. Well, what do I have to take away from 10 to get 1? 9. So I know that that missing number is 9. So I know that x has to equal 9. This is just thinking logically, just asking myself, what does that number have to be to make it true? Because then this would be 1 on this side, and this would be 1 on that side, so they are equivalent. This would be 7 on this side and 7 on that side, so they're equal, which is what we want. We want both sides to be equal. However, not every equation is that obvious. We can look at an equation and they aren't as easily to logically think through. So one way we can do this is describe what's happening to the variable and then undo it. Because there's some stuff happening to this x. It's being multiplied, whatever the x is, it's being multiplied by the 2. After it's multiplied, we're adding a 4, and then we must get a 12. That's kind of hard for me to think. I could guess numbers and try and guess and check, but we can do a step of undoing. It's very similar to losing something. You have to retrace your steps, which is just reversing what you did to try and find what you lost. This is the same idea we're going to use to solve equations. What does that look like in terms of finding the answer? This is one technique that I kind of have used in the past. So I draw a line down to talk about what's happening to the variable. Let's move this over a little bit. So in order, this variable x is being multiplied by 2. After the multiplication by 2, the next thing that happens to this thing is we're adding 4. Okay? So that's what happened to the x. So if we want to retrace our steps, we need to go backwards and reverse and retrace them. That means that instead of adding 4, we're going to subtract 4. And then instead of multiplying by 2, we're going to divide by 2. Okay? Now, a lot of you know how to solve this just by looking at it because you've done it so many times, but I'm trying to explain to you why this is what we do. always draw a line through here. If you're getting wrong answers and don't have that line, I'm going to make you go back and redo it because this helps us keep track of things. So look at my steps first. I'm going to start here. First step is subtract the 4. So I'm going to subtract 4 on both sides. I cross it off, draw a line under. Now I bring down whatever's left over, which is the 2x. Then I do 12 minus 4 to get 8. So subtracted 4, done. The next step says divide by 2. So I'm going to divide by 2 on both sides. These 2's cancel out because they become a 1. So I've got x by itself, and then 8 divided by 2 is 4. So that is my final answer. Now I can always check this answer. I can always plug it back in and make sure I did it correctly. So I can say 2, and then instead of x, I'm going to put a 4 in there, and I'm going to see if it equals 12. 2 times 4 is 8. Bring down the 4, and then 8 plus 4 is 12, so I did reverse correctly. Okay, so if you're unsure of an answer, the best part about this entire learning target is if you come up to me and say, is this answer right? If you plugged it back in and checked, then it should be right. Okay? Cool. You don't have to do that reverse thing every time. If you want to, you can. I'm going to do it for the first one just to show you that it does actually work. So if I'm tracing my steps, the first thing that happens to the x is we multiply it by 4. And then the next part is we add the 3. So that's what's happening to the x. If I want to reverse this and figure out my steps, then I can reverse and say we're going to subtract 3 and divide by 4. So my first step then, draw your line, subtract 3 on both sides. The 3's cancel. I bring my 4x down. Negative 17 minus 3 is negative 20. I don't want you doing this in your head. If you've got negatives and you try and do this in your head and get it wrong, I'm going to send you back and make you use your calculator. There's too many of you coming up and getting wrong answers because you just refuse to use the calculator, which is super weird to me. I don't know why. So please use your calculator if you are having trouble with negatives. The next step says divide by 4. So I did that step. Now I'm going to divide both sides by 4. And I get x equals negative 5. If I were to plug this back in and check, I would see that that answer is true. I'm not going to do that on the video because it would take too long. Okay? All right, the next one has a new thing, and it's got a set of parentheses. Now, this should not be unfamiliar. Okay? We just have to always distribute with parentheses. I don't know why my pen is like skipping letters. It's very strange. Never done that before. Okay, distribute with parentheses. So I'm going to draw my little distribution marks. Distribution means we multiply. So when I do that, I get negative 6x. Negative 6 times negative 1 is a positive 6. And then I bring my 18. Notice how I forgot my line? So I'm going to go ahead and erase and get my line in order because I don't want my work to be messy. So I'm going to rewrite that. Negative 6x plus 6 equals 18. Subtract the 6. Notice I'm doing this without my little guide, which is okay. If you need to do the guide, you can, but most of you should be pretty familiar with these. So once I subtracted my 6, and now I'm going to divide by negative 6. Sometimes I also like to write lines under here to help me split it up. That's okay too. Write my line to help me split that up. The negative 6's cancel out, and I get x equals negative 2. Okay. Again, if you need to pause and rewrite these if you want to listen to me first, go through and listen to me. Don't write anything down and then pause and write it down. That might help you learn it easier. Some of you try and write everything down and don't pause, and you come back and you've forgotten what you've written. So these kind of strategies as we get to harder math are really going to help you out. Okay. Last one for these simpler equations. Draw your line. Add the 5 over. The 5's cancel out. Bring your negative 4x down. And then 67 plus 5 equals 72. Now divide by negative 4 on both sides. Those cancel out, and I get that x equals negative 18. Okay. One thing to note is that you don't want to divide before you add. If you divide this 4 first and don't add the 5, there will be a mistake made. And I can explain that to you in person if you do want to know why that is. Okay, but I want to save us time, so ask me in person if you want to know the reason behind that. Okay, so now we're going to move on to an idea that is something students struggle with, and that's whether my variable is on the right side instead of the left side. So when this happens, we just have to rewrite our solution so the variable's on the left, and I'm going to show you what I mean by that. So I'm going to draw my line, and now I'm going to have to distribute on the right side. The negative 35 just gets brought down, and I'm going to multiply to get negative 15 minus 5k, okay? Because negative 5 times k is negative 5k. Okay, now I'm going to add this 15 over. I know it's weird because it's like backwards. These cancel out, and negative 35 plus 15 is negative 20. Again, use your calculator if you don't know. I'm going to bring that negative 5k down, divide both sides by negative 5. Those cancel. I get that k equals 4. Now, I don't like my variable on the left, so all I'm going to do is switch it around, so then k goes here and 4 goes here. I like this answer better. I like the variable on the left for your final answer, so just flip them. It means the same thing. If 4 equals k, then k equals 4. So it doesn't change the meaning, it just changes how it looks, and we want it to look professional. Okay? The last step of these equations is when we have variables on either side instead of just one. So we have to be really careful as we get to these kinds of equations. And what I'm going to do for you guys, I'm going to write a list of steps. So I'm going to put these on here, and as you get to these equations, you need to follow these steps, and you're going to be golden. So let's put that here. So steps. And these should work every time, okay? Step number 1, we are actually not going to learn in this learning target. That comes in 2.4. So don't worry about step 1 right now. You're going to skip this for this learning target. I'm going to talk about step 1 next time because it's complicated. Your second step is distributing. Okay? So in the first problem I see here, this negative 3 and minus 15, I don't see anything to distribute. Okay? Your third step then is to combine like terms. Now this is tricky. A lot of students make a mistake here. You always draw your line first, and when I mean combine like terms, I mean does this side have any like terms and does this side have any like terms? I get that the 5n and the negative 3n are like terms, but because they're on opposite sides, we do not combine them. Okay, so don't do that. Don't combine them. They get moved around. Okay. The fourth step then, because this equation has nothing in our first 3 steps, so we skip all 3 of these. Our fourth step is to get the variable on one side and the numbers, in fact, I'm going to use the vocab here, and the constants on the other. Okay, so here's what I mean by that. Let's use a different color here because there's like a lot of blue going on. So here's what I mean by that. Draw your line, and what we're going to do is we're going to get all of the variables on the left and all of the constants on the right. I like my variables on the left, like I said, so I'm going to go ahead and look at this negative 5n. I don't want the n on the right side, so I'm going to move it by doing the opposite. And then be really careful. If I do plus 5n here, I'm going to line it up with the like term on the right side, on the left side. That way I can clearly see that these two cancel, and then I've got negative 3 plus 5 to give me a 2n. This is important. I'm telling you right now, if you do not organize your work, you are going to make mistakes. I say this every year, and still students don't do this. So watch how I'm organizing. Replicate that. It will be very helpful. Bring down the negative 15 and then bring down the 1. Now I've got this negative 15 here. That's a constant, so I'm going to move it over to the right. They cancel, bring down your 2n. 1 plus 15 is 16. Now your last step is to divide by 2. Again, I'm going to put these lines here to help. So then n equals 8. Cool. I followed my steps. Okay. I'll even put on here for your step 5 is then to just do the reverse solving like we talked about in the beginning. And these steps will work for all of your equations. I'm going to also, this number 1, that's going to come later. So we can skip that step for now, but I want to make sure you know there is a step before the rest of this. So now let's try the next problem. Draw your line. Now the next step is to distribute. 7 times 7 is 49 with the x. 7 times 6 is 42. On the other side, just bring that down. One step at a time. All right, now I'm going to get all my variables on the left side. So I'm going to add 49x over. Draw my line here. These cancel. Negative 4x plus 49. Oh, I'm sorry. I made a mistake. I shouldn't add the 49. My bad. I should subtract that 49x. Okay, cool. That'll help a lot, because otherwise I would definitely get a wrong answer. So subtract 49x on both sides. Okay, cool. So now these cancel, and I get negative 53x. Wow. Negative 53x minus 11 equals, I don't know why I wrote a plus 40. Oh, equals 42. Sorry, guys, I'm really botching up this problem. All right, now we're going to add the 11. Get all the constants on that side. I get negative 53x equals positive 53. Divide both sides by negative 53. Watch your signs. And I get that x equals negative 1. Important are signs. Okay? All right, we've got 3 more problems, I believe, to work out. They're a little bit scarier, but still follow the same steps. Okay? So sometimes we got equations where we have to distribute on both sides. Okay? Don't be scared. It just means we have to do a little extra steps. So draw your line. Draw a long one for this problem, probably. We're going to distribute, and I distribute both at the same time. So I get 5x minus 15 plus 2x equals 4 times x is 4x, 4 times 3 is 12. Now I'm going to remember the step that I put down here, which is to combine like terms. So when I look on this side here, on the left side, I'm going to use my highlighter, I see that 5x and 2x are like terms. So I've got to put those together first before I move anything around. So 5x and 2x gives me 7x. They're combined. Bring down the minus 15, then bring down whatever's over here. Now I can start moving my letters and my constants. So I'm going to subtract 4x on both sides. These cancel. 7 minus 4 is 3x. Bring down your negative 15. Bring down your 12. Now get those numbers over there. Draw your line. Cancel. 3x then equals 27. Divide both sides by 3. These cancel, and I get x equals 9. Okay? Cool. All right, 2 more. Now this one looks terrifying. I get it. There's like a billion things going on. Okay, but this one I need to highlight something really important that is different. I get that there are 3 things to distribute, but that's not even what is different about this problem. The difference in this problem is something in the distribution. So I distribute the 3 here and here, but what the heck is happening here? What is happening here is you've got an invisible coefficient. This minus sign is actually a negative 1. So when you distribute this, you're actually distributing a negative 1 to both of these things. There will be a question like this on the test and on the mastery. I'm telling you right now that this idea is critical because you'll make a sign error if you don't do this. So let's distribute all this stuff. Okay, so the first thing is 3x minus 12. Negative 1 times 3 is negative 3x, and negative 1 times 4 is negative 4. The next distribution is 4 times 3, which is 12. 4 times negative x is negative 4x, and then just bring down the 5x and the 4. Now we've got to combine like terms. So on the left side, I'm going to be combining negative 3x and 3x. On the right side, I'm going to be combining the negative 4x and the 5x. I'm also going to have to combine my constants. So I'm going to combine negative 4 and negative 12. And I'm going to combine positive 4 and positive 12 on this side. So here's what this is going to look like now. So now when I combine the negative 3x and 3x, 3 minus 3 is 0. And a lot of you missed that on the mastery in one learning target where you were combining like terms and you tried to say 1 here, but those just cancel. So I just draw an x through them. I don't even need to write anything down. I can just draw an x. So now I have to do negative 12 minus 4, which is negative 16. Okay, so I like to cross them out when I'm done as well, so I know I've used them. On the right side, I've got negative 4x and 5x, which gives me a positive 1x. Okay, done and done. 12 and 4 give me a positive 6. Oops, I don't know why I wrote 12. That's weird. Gives me a 16. Oh my God, I wrote 12 again. What is happening? 16. Cool, there, I did it. All right, so now we've got something much simpler to work with. So I'm going to get my numbers on one side. So I'm going to subtract this 16 over here. That cancels out. Negative 16 minus 16 is negative 32. It is not 0. Signs are important. They're critical. And then I get x equals negative 32, and I don't have to go any further. So even though this problem looked really scary, it actually had a lot of steps that canceled out. So sometimes scary problems, if we are organized, use colors and cross out, we can make it very simple for ourselves, okay? The last problem just highlights something where there's no distribution, but there is some combining like terms going on. So when I look at this problem, I can skip the distribution step, but I've got to really notice that I've got a 4x and a 6x on this side, and then on the right side I have a bunch of numbers that I have to combine. So I've got a 3, a 4, and a 16 that I have to put together. So I'm going to draw my line. I'm going to combine the negative 16, 4, and 3. Now this is where I would definitely use a calculator even for myself because I don't want to mess that up. So I'm going to put in negative 16 plus 4 plus 3 and make sure I get that correct. That is a negative 9. So I'm going to bring down my 2x, and then I'm going to put minus 9 equals 6 and 4 give me a 10x, and then bring down that positive 7. Okay? Now we've got a problem that can't combine any more like terms, so I'm going to start moving my variables to one side and my constants to the other. So I'm going to get rid of this 10 over here and move it over here. Please notice how I'm lining things up every time. I'm lining the x's together to get myself organized. 2x minus 10x is negative 8x. Bring down your negative 9. Bring down that 7. Get the 9 over on that other side by doing the opposite. Cancel that out. Bring down your negative 8x. 9 plus 7 is 16. Then finally divide by negative 8. And you get x equals negative 2. Okay? So that's kind of all of the steps that we can work on for this learning target. I feel like I've really shown you some steps to organize. I've shown you how to use colors to combine like terms. I've given you a really nice set of steps that you can follow here. You can write them down on a card and you can have it next to you. I've given you a lot of tools. It is your choice whether to use them or not. Okay? This practice might take you a while, so I'd be surprised if you came up and were just done. That would alarm me. So be careful, take your time, and good luck.